Okay, we're back to look at the rational zero theorem. What this theorem will attempt to give us is a little bit of an educated guess as to zeros that are not integers. Now, what am I talking about? Let me show you what. So far, we've looked at, suppose we were going to factor something like x cubed minus 4x squared plus x plus 6. And we've said, well, if it does factor, it's going to look something like this. We're going to get x, x, x. And then this number here times this number here times this number here has to make positive 6. And we only looked at integers, things like 1 times 2 times negative 3. But that isn't just the only numbers that are available. What about rational numbers, which means fractions? I mean, you could do something like this. What if I said positive 1, okay, and then I said positive 12, and you're going, whoa, 12 isn't a factor of 6, and you're right. But then over here I have positive 1/2. Why not that? Because 1 times 12 is 12, times 1/2 is 6. So there's a lot of other possibilities that we haven't considered because generally fractions are kind of uglier to work with. But why not consider them? I mean, what if it's fractions that we're looking for and we can't find them because we just don't have some sort of a technique to do that? Well, this theorem gives us that technique. It tells us how to list all of these possible candidates, including fractions. So not just the whole numbers and the integers, but rational numbers, fractions as well. And it's very simple. Here's what we do. We would take the number at the end, okay, and we'd list all the factors of 6. So while there's plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So we still have those candidates. But now what you got to bring into the picture is you go to the very front, okay, as long as things are in descending order. So we find that term with the biggest exponent. We say, well, the coefficient here is a 1. What are all the factors of 1? In this case, very simple, just plus or minus 1. So now what we would do is we'd say, well, if we consider these numbers to be numerators, or top numbers of a fraction, and these numbers to be the denominators, or the bottom numbers of a fraction, and we put as many combinations together, then that's going to list not only these integer numbers, but possible rational numbers. Now this example wasn't really very good, because putting a 1 on the bottom isn't going to make any fractions for us. So I'm just going to add one little twist here. Suppose we had a 2 sitting out front. Okay? So instead of 1x cubed, it's 2x cubed. Well, the other factor of the number 2 would be plus or minus 2. So now we are going to have some possible fractions. So I'm going to list all of my possible zeros. That's why it's called the zero theorem. And what that means is these are possible numbers that when you plug them in for x, turn the whole polynomial into 0. In other words, these are numbers that produce remainders of 0. So what are my possible candidates? Well, let's list them. These are the top numbers, so I have plus or minus 1 over plus or minus 1, which is just going to be plus or minus 1. But I also have 1 over 2. And the plus or minus thing, I'm just going to write that for all the terms, so I'm not even going to repeat it again. But essentially a top number of 1 and a bottom number of 2. So 1/2 is a possible fraction that might be a 0. Okay, well that was 1 over both of these. Now I go to the 2. I go, okay, well 2 over 1 plus or minus 2. And 2 over 2 is going to just be a 1. Well, we have that already, so we're not going to write it again. Then I move on to the 3. Okay, well, 3 over 1 plus or minus 3. 3 over 2. Okay, well, we don't have that one, so plus or minus 3/2. Another possible fraction type answer here. And lastly, the 6 over 1, so plus or minus 6. And 6 over 2, well, 6 divided by 2 is just 3, which we already listed. So there it is. This is the complete set of possible zeros that are integers or rational numbers. And so now if I was going to try and factor this thing, this would be the actual candidates that I would actually plug in for x and see whether or not I get remainders of 0. And let me give you a little tip. Try the easy numbers first. Try plus or minus 1. Hope that you find 0. If not, I usually go to plus or minus 2. And then if that doesn't work, I go to the next easiest whole number. I basically do all the whole numbers first. And if those don't work, then I start with the fractions. Now, my suggestion is that you would just, if you're going to plug in, for example, 1/2, change it to a decimal, that is 0.5, and just type it all in on your calculator. Go 2 times 0.5 cubed minus 4 times 0.5 squared plus 0.5 plus 6. Now do it on your calculator. Okay, let me just do one last example. If I said list all possible rational, and that's the key word, because that means not just integers, not just nice whole numbers, but possible fractions, rational zeros of, and we'll say we have 5x cubed. Actually, let's make this one to the 4th, something really scary, minus 10x cubed plus 3x squared. And we'll say there's no x term, and then we have minus 4. Okay, so here's what you have to do. You go and say, well, what are the factors of 5? Plus or minus 1 and plus or minus 5. Those are the only two factors of 5. We go over to the number at the end and list its factors. 1, 2, 4. And then we think of these as the top numbers and these as the bottom numbers, and we mix and match them until we have a complete set of whole numbers and fractions. So here's what it's going to look like. Okay, we got 1 over 1. Now, what a lot of people like to do is they do it this way. They go 1 over 1, 2 over 1, and 4 over 1. So they get kind of all the nice whole numbers, integers, out of the way first. Okay, now I'm going to do all the other ones. So I got 1 over 5, 2 over 5, and lastly 4 over 5. And there they are. And if I was going to try and factor this, I would definitely start with these nice to work with numbers and only go to those if nothing else was working for me. Okay? That's the rational zero